Superhot rock geothermal energy can be generated from dry rock that's at least 752 degrees Fahrenheit. It exists all over the Earth at depths between 2 and 12 miles. With investment in innovation, this category of clean, baseload energy has the potential to be cost competitive with other zero-carbon technologies, while having a small land footprint. Less than 0.2% of global energy is currently generated from conventional geothermal, because it requires heat and water to be relatively close to the surface of the Earth. The core of the Earth is very hot, somewhere between 7,952 degrees and 10,800 degrees Fahrenheit at the very center. If we can drill down from the surface into what's called superhot rock, then we could access the heat of the Earth and turn it into a massive source of zero-carbon, always available energy. This category of clean, baseload superhot rock energy has the potential to be cost competitive with other zero-carbon technologies while also, very critically, having a small land footprint. Calculations show that it could eventually cost between $20 and $35 per megawatt hour, which is competitive with what energy from natural gas plants costs today.
Currently, there are no superhot rock geothermal energy systems operating and delivering energy. But money is flowing into research projects and companies that are working to develop the technology.
Superhot rock energy can be commercialized in the 2030s, and argues that its unique set of features, it's a clean source of inexhaustible baseload energy with a small footprint, make the investment worthwhile.
It will take public and private investment similar to those being allocated to nuclear, carbon capture, and hydrogen fuels. Geothermal programs receive far less funding from Congress and the U.S. Department of Energy than these other programs. Superhot rock geothermal isn't even in the decarbonization debate, but given a decade or two of aggressive investment, it could be producing baseload power, energy-dense, clean, firm, and competitive, from a price perspective.
While energy from superhot rocks is not being used now, geothermal energy is being used in a few places where superhot temperatures exist close to the surface of the Earth. Currently, about 16 gigawatts of power come from geothermal globally. That's less than 0.2% of the world's total. For comparison, there is 2,100 terawatts of capacity for coal energy globally and 1 terawatt of capacity for energy generated from photovoltaics, or solar panels. But accessing superhot rock energy involves tapping into hotter, dry rock, which is everywhere, but sometimes far beneath the surface. The deepest borehole ever drilled in the Earth went down almost 8 miles in the Kola Peninsula of Russia in the 1970s, but the rock there was not nearly as hot as 752 degrees Fahrenheit, the minimum required for this type of energy. Rock starts melting at between 1112 and 1832 degrees Fahrenheit, so the functional window for superhot rock geothermal is roughly between 752 and 1022 degrees Fahrenheit, Hill said.
How far you have to drill to get to 752 degrees depends on where you are. On the edges of the tectonic plate boundaries, or near recent volcanic activity, it might be 2 miles down, but in the middle of a continent, you might have to go down 12 miles.
Water would be pumped down into the hole and returned to the Earth in a superheated state known as supercritical, which has the properties of gas and liquid at the same time. That supercritical water would then be directed to power generators. A superhot rock energy system would have some carbon emissions associated with the construction of the plants, but because the working fluid, water, is injected into dry rock, there are no such hydrothermal-related carbon dioxide emissions. Iceland is a leader in investigating superhot rock geothermal energy with its Iceland Deep Drilling project. A test there suggests one well could produce 36 megawatts of energy, which is 5 to 10 times more than the typical 3 to 5 megawatts of energy a conventional geothermal well could generate. Iceland, Italy, Japan, New Zealand, and the United States are leaders in superhot rock geothermal. Other areas on the edges of tectonic plates, including Central America, Indonesia, Kenya, and the Philippines, also have some development. For superhot rock geothermal energy to be commercialized and deployed broadly will require new technology, including rapid ultra-deep drilling methods, heat-resistant well materials and tools, and ways to develop deep heat reservoirs in hot and dry rock. So far, private investment in the superhot rock space is very small. Oil and gas companies could use their resources to help spur development in the superhot rock industry.